The Earth's climate is a complex and interconnected system. It relies on a delicate balance of many factors. One crucial element, often overlooked, is the Atlantic Meridional Overturning Circulation, or AMOC. This massive ocean current acts as a global heat pump. It transports warm water from the tropics northward, moderating temperatures and influencing weather patterns across the globe. For millennia, AMOC has operated with remarkable consistency, playing a vital role in shaping the climate we know. However, this vital system is now under threat. Climate change, driven by human activities, is disrupting the delicate balance that keeps AMOC functioning. Scientists warn that if we continue on our current path, we risk pushing AMOC past a tipping point. This could lead to its collapse, with catastrophic consequences for the entire planet. Understanding AMOC and the potential impacts of its collapse is crucial for comprehending the urgency of the climate crisis we face. The fate of AMOC is intertwined with our own. As we delve deeper into this critical issue, we will explore the science behind AMOC, the potential consequences of its collapse, and the actions we can take to avert this looming crisis. The time to act is now, before the ocean's engine grinds to a halt, leaving us to face the consequences of a world irrevocably changed. Imagine a giant conveyor belt flowing through the Atlantic Ocean. This is a simplified way to picture AMOC, a powerful system of ocean currents driven by differences in water density. Warm, salty water from the tropics flows northward along the surface of the Atlantic, carrying heat towards Europe and the North Atlantic. As this water reaches higher latitudes, it cools, becoming denser and heavier. This denser water then sinks and flows southward in the deep ocean, eventually completing the loop. This continuous cycle of warming, cooling, sinking, and upwelling acts like a giant pump, distributing heat around the globe. AMOC plays a crucial role in regulating global climate patterns. It helps moderate temperatures in Europe, influences rainfall patterns, and even affects the intensity of hurricanes in the Atlantic. Without AMOC, the world as we know it would be a vastly different place. This intricate system, however, is highly sensitive to changes in temperature and salinity. The influx of fresh water from melting glaciers and ice sheets, a consequence of climate change, is disrupting the delicate balance that keeps AMOC functioning. As fresh water enters the North Atlantic, it dilutes the surface water, making it less dense and less likely to sink. This disrupts the flow of the current, weakening the entire AMOC system. The collapse of AMOC is one of the most feared tipping points in the Earth's climate system. While scientists are still working to fully understand the potential consequences, the implications are deeply concerning. An AMOC collapse would have profound and far-reaching effects on global climate, weather patterns, and ecosystems, with devastating consequences for human societies. One of the most immediate impacts would be a dramatic cooling of the North Atlantic region, particularly in Europe. Without the northward flow of warm water from the tropics, temperatures in Europe could plummet, leading to shorter growing seasons, reduced agricultural productivity, and potential food shortages. Paradoxically, while Europe shivers, other parts of the world could experience more extreme heat waves and droughts as the global climate system readjusts to the disruption of AMOC. The impacts of AMOC collapse would extend far beyond temperature changes. Sea levels along the eastern coast of North America could rise significantly faster than in other parts of the world. This is due to the disruption of ocean currents and the gravitational pull of water. Furthermore, shifts in rainfall patterns could exacerbate droughts in some regions and trigger more intense monsoons in others, leading to widespread crop failures, water scarcity, and increased risk of natural disasters.